Hello, my name is Fabian and I'm a fourth-year PhD at New York University. Today I will tell you about P4Testgen, a tool which you can use to generate packet tests for network data planes. We have developed P4Testgen at Intel in collaboration with NYU and Cornell. Let me first provide you some background why we have developed P4Testgen. Data plane toolchains, so the software stacks we use to ensure that a network device processes a packet correctly, are becoming increasingly complex. And since we want to make our networks more scalable and reliable, we have been introducing new orchestration layers and also specialized hardware such as SmartNICs or switches. Complexity grows in depth with the amount of abstraction layers we add, and in breadth as we get more software and device choices per layer. I'm listing a bunch of options on the slide. They by no means are exhaustive, but already overwhelming, right? To gain control over this complexity and to understand what software pieces to actually deploy, we are starting to describe the functionality of our network data plane in the form of an abstract model. These models describe the functional intent of the data plane. More specifically, the input-output packet behavior expected from the data plane functions we want to deploy. The models are programs written in a packet processing DSL, such as P4. In a program, you describe the network functions you want to test, for example, packet encapsulation or access control. The model is often interpreted by an emulator, which uses a software stack that is almost identical to the final implementation of the data plane function. We've been seeing such models written in various levels of fidelity, from coarse network-wide data plane perspective down to modeling the behavior of a single hardware device stack. Well, once you have a data plane model, you can prototype your data plane functions before you deploy them. I will first go into detail how this process works, and then explain a bunch of shortcomings of it, which motivated us to develop P4Testgen. Now, imagine you want to integrate a firewall into a new switch in your data center, but you're unsure about the exact soft and hardware pieces you need to accomplish that. To approach this problem, you will first start to write a model. And this model captures your intent on how this firewall is meant to behave on that particular switch. You then write input and output packet tests against the model emulator with a software deck that is close to what you want to deploy. And then you run these tests against the model and build it out. Once you feel confident with your prototype, you can start to instantiate a real deployment and run the exact same test you used for a model on this instantiation to identify any problems, discrepancies, or issues. You can repeat this process until you feel confident in your deployment. Google's SwitchV from this last year's SIGCOMM' and Microsoft's CrystalNet papers describe examples of how this process can work. Now, this particular approach of data plane prototyping sounds interesting, but there's a little problem, and that is the tests. Writing these packet input-output tests is really difficult. We're working with packets on the level of bits and have to write bit-exact header sequences. Further, you want to cover specific features, and for that, you might have to instrument a lot of control plane instrumentation to really get the path you want to cover. This is tedious and also error-prone. The code plot I'm showing here is how a real Python packet test looks like. And you need it for a Tofino data plane model just to forward a TCP packet. Lots of hex code, right? So in practice, we don't write a lot of these tests because of how exhausting it is. Thankfully, packet processing is fairly constrained as a domain, and so are its specification languages. This makes it easier to apply formal methods and develop things such as test case oracles. So, instead of tediously and manually writing our own tests, we can just generate them. We feed our function model into a test case oracle, and this test case oracle is specialized to the packet processing semantics of our particular data plane. For example, we can feed the firewall model from earlier into an oracle specialized to our target switch. The switch test case oracle will then generate the packet tests, which exhaustively cover the input-output packet behavior of our firewall running on this particular switch. Well, we make this sound easy, but based on first-hand experience, we know that building a test case oracle is really difficult. We need to understand the semantics of the modeling language first, and then we need to understand the semantics of the data plane we want to test, so a switch or a SmartNIC. And then we need to know which kind of formal methods to use and how they work. Lastly, we also, of course, need to understand how to design a compiler, interpreter, and use particular sophisticated testing methodologies. Finding a software engineer that can really do all and want to do all of this is really difficult. And as an open source project maintainer, we've been struggling to find people. So one may think there's tools already available which can generate tests for you. However, available tools, they're really specialized to describe only the packet processing semantics for their particular data plane. For example, MISA for the Tofino switch, or switch-v for a specific fixed function switch ASIC. You've seen from the first slide how diverse data planes are now, and how more diverse they're going to get. Device manufacturers such as Intel and network operators such as Microsoft or Google, they're dealing with many different data plane functions they want to test and deploy. And they also design for switches, smart NICs, and OS networking stacks. Building a test case oracle per particular data plane, it will cost a lot of effort, it will cause redundancy, and ultimately will not scale. Again, we were faced with this really exact problem, and ultimately what we really wanted is a generic test case oracle for us. And what this test case oracle does, it takes an input, the model of the data plane function we are interested in, and a concrete specification of the data plane stack we are running it on. With this particular inputs, the oracle will just generate input-output tests for us. P4Testgen is an instantiation of this idea. Now, what is P4Testgen? P4Testgen is an oracle. It's a test case oracle, and it takes as input an abstract data plane model written in the P4 language. It also takes a concrete data plane specification for, let's say, the Tofino switch. And we can do this with P4 because it describes packet processing on a bit-precise level, and in combination also uses a package system which allows us to extend the language to many different data plane scenarios. So it's very flexible. P4Testgen is an oracle designed for single input-output packet tests, and it generates the test using an SMT solver. With this test, P4Testgen tries to cover the entirety of the given P4 program, and with that, we mean that we cover the functionality of the data plane you really want to model. Most importantly, P4Testgen is extensible, and the extensions are what supply the packet processing semantics that you need to be able to generate correct tests for your data plane. At this point, we have written extensions for Tofino 1 and 2, eBPF, DBDK, and SmartNIC data planes. Well, what does P4Testgen really actually do? Recall the switch firewall we wanted to implement earlier. Let's assume this firewall routes or drops Ethernet or IPv4 packets based on the Ethernet source address. We model this behavior in P4. P4Testgen will then ingest the P4 model, identify the portions of that program which correspond to input, the control plane configuration, and the corresponding output of the function. It will then exhaustively produce tests for all possible outcomes identifiable in this model. In our example, we may get an Ethernet or IPv4 packet, which we can then either forward or drop. So, 4 unique tests. The developer who uses P4Testgen can then just choose the test they find interesting or relevant. To be able to generate these tests in such a fashion, we had to solve a series of technical challenges. And since this is a short talk, I will not go deep and just provide a brief overview of the challenges. Broadly speaking, we had to make sure that we can bridge gaps in the P4 language, which only describes the behavior of programmable blocks, but not what happens in between these particular blocks. We also had to handle data plane functions such as hashes, checksumming, and general randomness, which makes symbolic execution with the SMT solvers particularly difficult. If you're interested to learn how we solve these problems and to understand the limitations of our current approach, please see our paper. Overall, we consider our idea a success. At this point, we are aware of 7 extensions to our tool, all of which are able to generate tests. And with these tests, we have found around 30 bugs in the toolchains for the Tofino 1, 2, and the behavior model. Not to mention the variety of bugs we are detecting in emerging toolchains. We've also applied P4Testgen to the P4 data plane models of the pins and dash projects. And here we found issues where the data plane models were trying to describe scenarios which were not executable on the data plane they were targeting. We were able to find these bugs because P4Testgen was modeling the packet processing precisely enough with its extension model. Also, our list of users is growing. So currently we are interfacing with chip vendors, network equipment manufacturers, and also large network operators. To conclude, we think that because of the complexity of toolchains, data plane modeling will only increase in popularity. However, to make it succeed, because writing tests is hard, you should really use a test case oracle to supplement testing. And P4Testgen is such an oracle that can generate tests for you. So if you have a P4 data plane, or you're building one, you should really use P4Testgen. It will make your job a lot easier. If you're interested in this project, please reach out to us. P4Testgen is intended as a community project, and it's open source and already available as an extension to the official P4 compiler. If you're familiar with that ecosystem, bootstrapping will take you no time. Thanks for listening to this talk.